Electrons move around a nucleus of an atom in concentric orbits. These orbits or shells represent different energy states that electrons can exhibit. The farther an electron is from the nucleus, the greater its potential energy. While electrons typically remain in their prescribed orbital energy level, it's possible for an electron to be knocked from its lower orbit into a higher one. Thus, a bombarding free electron can collide with a bound electron, raising it to a higher orbit or energy level. This electron is now in a state of excitation. However, this higher orbital status is fleeting. The electron will be quickly drawn back toward the nucleus and return to its original orbit. During this transition back to its normal state, a single photon of visible light is emitted. This repeating sequence of electron excitation followed by de-excitation is the basis for the functional capacity of a fluorescent light bulb. A typical fluorescent bulb is filled with argon gas and a minuscule amount of vaporized mercury. The inner surface of the tube is coated with the powdery phosphor substance. At each end of the tube is an electrode with filaments. When heated to a high temperature, they emit or boil off electrons. An AC voltage pulse supplied by a starter pushes the electrons from one end of the tube to the other. If one of the free electrons collides with an electron of the mercury vapor, the electron is bumped from a lower to a higher energy level. The electron quickly returns to its lower energy state and in the process releases an ultraviolet photon. This photon is then absorbed by the electrons of the phosphor powder lining the tube, again exciting electrons in the process. This excitation is followed in turn by de-excitation and the release of a low-frequency photon. The photons from all these reactions combine to produce the glow of white light, characteristic of fluorescent bulbs.
What if there is only one electron in the whole universe? What if every electron is the same electron? A vaguely plausible thought experiment posits that every electron is one electron moving back and forth through time. Here's a question you've probably never considered: why are all electrons the same? Every electron in the universe has exactly the same mass, exactly the same charge, and if you think about it, there's no reason why they'd have to be. In 1940, physicist John Wheeler came up with a novel new theory that might explain why all electrons are identical. According to him, the reason that every electron is the same is because every electron is the same electron. There's a lot of complicated physics involved, but simply put, one electron theory might be possible if every electron in the universe is the same electron, bouncing backward and forward in time. Just as an electron can be bounced around in space when hit with light, there might be a way to bounce an electron backward in time. If that's the case, then there's another consequence of this theory: electrons moving backwards in time are positrons, the antimatter component of electrons. Not only are all electrons the same electron, but all positrons are also the same electron moving backward. This is an interesting idea, but it's far from proven. There are plenty of problems, such as why there are so many more electrons than positrons or why there are the number of electrons there are. After all, if a single electron can bounce backward and forward through time forever, why aren't there an infinite number of electrons? But if it is true, what else might it mean? Perhaps every other particle, from protons to neutrons to exotic particles like neutrinos, is all just one particle bouncing back and forth through time. That would mean that not only are we all made of the same kinds of stuff, but in fact each of us is made using just one proton, neutron, and electron.